Section 11.3, Part 1, Inference about two proportions. Lesson objective: test hypothesis regarding two population proportions. Here are some headlines of recent news stories. Males are more likely than females to be binge drinkers. A 20-year-old obese person can lose 20 years of life. Religion more important among Americans than Europeans. Drinking tea may help heart attack victims. TV violence linked to aggressive behavior. Pick up a major newspaper any day and you'll likely see a story with the headlines like these. Such stories usually refer to research studies that use statistical methods to make inferences. Most commonly, the studies involve a comparison of two groups, or two treatments, such as males versus females, obese versus non-obese, drinking tea versus not drinking it. Lesson objective: sampling distribution of the difference between two proportions. Suppose that a simple random sample of size n1 is taken from a population where x1 of the individuals who have a specified characteristic and a simple random sample of size n2 is independently taken from a different population where x of 2 of the individuals have a specified characteristic. The best point estimate of p is called the pooled estimate of p, denoted p hat, where p hat is the sum of the x's, the characteristic that we want, divided by the sum of the two different sample sizes. The test statistic for comparing the two population proportions is a z, and here's the formula, which breaks down to this. We're not going to compute this by hand. We're going to let Minitab and StatCrunch compute this for us. Hypothesis tests regarding the difference between two population proportions. These are our three assumptions. The samples are independently obtained using a SRS, simple random sampling. The sample size of the first group times the p hat of the first group times 1 minus the p hat of the first group has to be greater than or equal to 10, and the same thing for the second group. Both sample sizes from the two groups have to be less than or equal to 5% of the original population. So those are our three assumptions. Let's look at our steps. Step 1, just as before, we determine the null and the alternative hypothesis. That can be one of three ways: a two-tail, a left tail, and a right tail. A two-tail, the null is P1, the proportion equals the other proportion, and the alternative is a not equal to. This is why we call it a two-tail. Left tail, again, the null assumes the two proportions are equal, and for a left tail, proportion 1 is less than proportion 2. And for a right tail, the null, again, we have an equal sign, the two proportions are equal, and the alternative is the first proportion is greater than the second proportion. Step number 2, alpha, or level of significance, and that is the probability of making a type 1 error. Step 3, the test statistic is given by this formula, and our p hat is this pooled estimate of p. Step 4, we can compute the p-value. Step 5, if the p-value is less than or equal to alpha, we will reject the null and conclude the alternative. Or if the p-value is greater than alpha, we fail to reject the null. Step number 6, just as before, we state the conclusion in English. Let's do an example. Do airbags really help? The table below lists results from a simple random sample of front seat occupants involved in car crashes. Use a 0.05 significance level to test the claim that the fatality rate of occupants is lower for those in cars equipped with airbags. So we have our alpha level. The claim is we want to see if it's lower, so this is going to be a left-tailed test, and here we have our summarized data. This is how many people died out of this many who had airbags, and then this is how many that died out of this number, 9,853, that had no airbags. And we want to see, is there a significant difference between these two proportions? Okay, let's check our 3 requirements. 2 simple random samples. The 2 samples are independent. That's a safe assumption. Here's our proportion for the airbags. This is the proportion for the non-airbags. And if we plug in our values for our assumptions, we see that 40.9 is greater than 10, and for our second group, the no airbags, is 51.7. So the second assumption is satisfied, and the third one, the sample size is no more than 5% of the population size. That is true if the population is all drivers, with airbags and without airbags. So our assumptions are satisfied. We'll do our 6 steps. Step number 1, we state the null and the alternative. Our assumption is the proportions are equal. The proportion of airbags equals the proportion of no airbags. And this is the same thing as if we were to write the proportion of airbags minus the proportion without airbags equals 0. For the alternative, it's a left-tailed test where airbag is our first proportion. And we can also write that proportion of airbags minus proportion of no airbags is less than 0. Step number 2, our alpha level is 0.05. Step number 3, our test statistic. So here we have our pulled p-hat, and if we plug it into our formula, we see that the z is a negative 1.91. Now I'm going to show you how to use Minitab and StatCrunch to compute this. In Minitab, we go to Stat, Basic Statistics, to Proportions. We have Summarized Data, so we select Summarized Data. And for the first, we're going to put our airbags. Events is our X, 41. Trials is N, which is 11,541. The second is non-airbags, which is 52 deaths, and that's out of 9,853. We click Options. Test difference is 0, that's what we want. We have to click Use Pulled Estimate for P for test. And then in the alternative, we have to change it from a not equal to, a two-tailed test, to a left-tailed test, a less than. We click OK. And in the session window, we see that the z-score is a negative 1.91. The p-value, which is step 4, is 0.028. In StatCrunch, we go to Stat, Proportions, to Sample with Summary. We enter airbag deaths and the sample size. Sample 2, we enter 52, and then number of observations, that's N, 9,853. We hit Next. The difference is a default of 0, and that's what we want, and we just need to change the alternative from a not equal to a less than. We hit Calculate. We see that the z is a negative 0.91 with a p-value of 0.028. So step 4, from Minitab and StatCrunch, we see that the p-value is 0.028. This is from table 5, 0.0281. We have our picture with our left tail. So step number 5, because our p-value is less than alpha, we reject the null and we conclude the alternative, that the proportion of airbags is statistically less than the proportion of no airbags. So step number 6, at the alpha equals 0.05 level of significance, there is sufficient evidence to support the claim that the proportion of accident fatalities for occupants in cars with airbags is less than the proportion of fatalities for occupants in cars without airbags. Based on these results, it appears that airbags are effective in saving lives. Thanks for watching.